Howdy guys, got a video here for you today on the Cricket 2 Tactical, and what we're going to be doing in this one is making an offset shroud for the rifle. Now I don't typically like doing offset shrouds because of the way the air interacts with the baffles, so we're going to be making this one slightly different. This one will be a dual layer shroud with a smaller concentric shroud nested in a larger offset shroud. Now don't worry, you'll see exactly what I mean as we walk through the build. First up, we're going to be making our concentric core. This is our standard shroud core design and starts off life as a lump of aluminium 26mm OD and about 170mm long. The first operation is to thread the end to suit the M14 by 1.25 thread on the barrel. To do this, we centre drill the end, pilot drill using an 8mm drill 25mm deep, then come through with a 12.5mm drill and drill 15mm deep. With that done, we can finalise the bore to 12.8mm, 17mm deep. Now this is tapping size for M14 by 1.25 and the correct depth for the barrel threads. Now this hole needs a flat bottomed hole to allow the shroud to reference against the face of the barrel. So that's why we're using a boring bar for this job rather than just using a 12.8mm drill. Whilst we have the boring bar in the tool post, we are also going to create a small thread gutter so that the threads can end nice and cleanly. Finally, we can come through with a spiral flute tap and get the threads put in. With that done, we can test fit the barrel and check for any run out. Now a tiny wobble is fine, but any excessive run out could be an indication that there's something wrong with either the threads on the barrel or the threads in the back of the shroud. But I'm happy to say that R1 seems to be running nice and true, so we can move on to the next operation. The next thing to do is to chuck up our M14 by 1.25 mandrel and make sure it's running nice and true. This is a homemade steel mandrel and is what we use to ensure all work done from this point will align with the threads. Once it's checked to be running true, we can face the end to put a fresh face on just in case it's picked up any nicks from storage. And with that done, we can screw on our core and start work. First we need to centre drill the end, being careful not to put too much pressure on it, as with this much stick out we could easily knock the core out of alignment. And then with that done, we can get our tailstock support in and start turning the external features. First we're turning the end down to 25mm and then back turning the rest of the core down to 23mm. This core will have a 25mm carbon fibre tube slid over it, and the core needs to be a nice close fit on it. We're back facing simply because it works out a little easier this way, as we don't have to plunge straight into the material with a tool. The lathe is spinning in the same direction, it's just the feed direction which has been reversed. Once that's done, we can move on to drilling out the centre, and this will be the path that the pellet travels through. First we're using a 5mm pilot drill to create a hole about 50mm deep, pecking about 5mm at a time. Then we can switch over to a long 5mm drill and drill the rest of the way through the core, using lots of WD-40 and pecking about 3mm at a time to ensure that the drill is not pulled off centre. You can also see me feeling the drill every now and again to check for any excessive vibrations or wobbling. Once the 5mm drill has broken through, I used a 6mm drill to open the hole up about 130mm deep. This will leave the first baffle at 5mm in diameter and the rest of them will be 6mm. Next we can remove the mandrel from the 3-jaw chuck and finish off the ends. First we're using a chamfer tool to relieve the threaded end, and then we can flip the part in the lathe and face the muzzle end to length. Next we can cut a small relief behind the major diameter for the carbon fibre tube to run up against. With that done, we can finish the lathe work off by putting an O-ring groove in the end, and the purpose for this will become very clear a little later on. We can finish the part off by moving it over to the mill and milling out the baffle chambers. First we're creating some pilot holes using a 6mm drill, and we're doing this because end mills don't typically like being plunged straight through material. Even centre cutting end mills prefer pilot holes. Next we can rough out the baffle chambers using one of my old 8mm 3-flute end mills. I don't mind this one recutting chips as it's already fairly blunt, so we're using this one for roughing, then I'll come back with a long 8mm 4-flute end mill to clean up the walls. The baffles are 2mm thick and the baffle chambers are slightly different sizes, which is something that we found to make a subtle difference to the noise of the shrouds. Last operation is to mill down the very ends of the shrouds, and this will just allow the air to move back through the shroud. With that all done, that's the core complete, and if you take a look at it, you can see the first baffle hole is 5mm, whereas the rest are 6mm. The last thing to do is to deburr it, which is something I'll do off camera. Next up, we can turn our attention to the eccentric aspects of the shroud. As we said earlier, the shroud will have a concentric core, and then around this we'll have an eccentric expansion chamber. To accomplish this, we'll be using two end caps, one fitting over the barrel and the other end over the shroud core. These end caps will capture a larger carbon fibre tube. Again, it will be much clearer once you see all the components together. We're only going to be showing the making of one of the end caps as they're very similar. But to start off with, we've got some Delrin chucked up in the lathe and we're turning a spigot on one end. With that done, we can flip the part in the chuck and work up on the other side. First we can face the piece, then turn it down to 40mm OD to match the carbon fibre tube, and then next we can turn a step for a close fit on our tube. This needs to be just under 38mm, and we can use our carbon fibre tube as a gauge to check the fit. Next we can put two O-ring grooves in the OD to seal on the carbon fibre tube. The easiest way to get the right squeeze on the O-rings is to cut the groove a little shallow, but the correct width, then fit an O-ring and measure across it. With that dimension you can then adjust the depth of the groove to fine tune the O-ring squeeze. Up next we can move the piece over to the mill and start work on the eccentric features. First we're drilling a location hole which will allow us to indicate the part in back over at the lathe. It's a 6mm hole 5mm from the centre, although as we're going to be using the 4-sided collet block to drill some securing grub screws, this hole needs to be drilled at a 45° offset. Next up we can rotate the part in the vise and get the holes for our 4 securing grub screws drilled through. These holes will be at 90 degrees to one another and also intersect with the eccentric bore. Finally, in this setup we can fit our carbon fibre tube over the part and get the holes for the securing grub screws drilled through the carbon fibre. This end won't be glued into the carbon fibre, so it will be removable, but we're going to secure it using grub screws. Again, it will make sense when we're over at the bench. With that done, the final operation for these pieces is moving them back over to the lathe and getting them chucked up in the forejaw. We have the part pushed on the end of a drill bit, and we're using this to get the position of the hole located near the centre of rotation. With that done, we can get the jaws tightened and then start work using a DTI to get the part dialed in. We need to get the hole running nice and true, so we're tightening the highs and loosening the lows. We could have bored the hole in the mill, but I don't have a proper boring head set up for the mill, and I am going to be cutting an O-ring groove in this bore anyway, so that's something I can only do over in the lathe. With it all centred up, we can drill out the centre to 13.5mm, and then come through with a boring bar to take it out to a nice close fit on the barrel, which is 15mm OD. We did also cut an O-ring groove in this bore, although I forgot to press record on the camera, so I don't have any footage of that. Lastly, we can turn the end of the back cap down, and this diameter will be used to support the back end of the carbon fibre tube, which will be our smaller nested shroud. With that done, we can finish the part off with our last O-ring groove, and there's the part pretty much finished. I'll get it parted off and then take you over to the bench and show you how it all works. Right then, and that's pretty much how we made the shroud. What we'll do now is take a quick look at the individual components, then we'll get it fitted to the rifle. So first up we have our inner core here. So this just screws over the barrel, and when we take a shot, the pellet travels through these holes here. As the pellet travels through them, air is blocked from moving forward, so it's forced backwards. when everything's installed in the rifle, this carbon fibre tube will fit over the core and stop air from escaping outwards, so it'll be forced back through these holes here and then into the larger expansion chamber. At the back here we have our back cap. This diameter here is a close fit on the carbon fibre tube, like so, and then we have the outer diameter here, which is a close fit on the larger carbon fibre tube. We have 4 securing grub screws, so 2 in the top here, which are used to secure the back piece onto the barrel. Then the 2 in the bottom are used to secure the carbon fibre tube and stop it moving forward. Lastly, we have our expansion chamber with the offset hole in the middle there. This end is glued into the carbon fibre tube. Then at the back here we have our 2 holes, which line up with these 2 holes here. Right then, so the way the shroud works is very simple. If everything's installed in the rifle correctly, when we take a shot, the pellet will travel through the baffles and block air from moving forward, forcing it back. It's obviously pressurized air, so it's always going to want to expand, and it's going to expand back through the shroud, through the holes in the back here, and into the larger expansion chamber. At the front here, we do also have a little breathe hole to allow the waste gas to escape. But that's the basic principle of the shroud. So we'll bring back the rifle and we'll get the shroud installed onto it. Before we do that though, I will just demonstrate the original shroud to show you the difference in noise between the two. So we'll get the rifle nice and close to the microphone, pointing it in a nice safe direction. With that done, we can get the new shroud installed. First thing to do is to remove the old one, so we can just unscrew that. Then we can take our back cap and get that slid over the barrel. Now I do have to align it, so if we look down it, might not be able to focus correctly, but as you can see here, we can rotate the back cap to get it aligned and misaligned. So I'll do that quickly. Then once we're happy with the shroud alignment, we can do up the 2 securing grub screws using a 2mm Allen key. Next we can take our inner carbon fibre shroud, get that slid over, and then screw our core onto the barrel. With that done, the final thing to do is to get the outer carbon fibre shroud installed. And that's nice and simple to do, as we only need to push it over. Now the only thing I will mention is that this diameter here locates on a boss inside of here, so everything's held in alignment. And that's the reason for the little O-ring at the front there. With the shroud pushed over, the last thing to do is get the 2 securing grub screws installed, one on either side, and again these are done in using a 2mm Allen key. And there we have the shroud all installed and ready to go. I am quite happy with the way it turned out. It does fit the rifle quite nicely. It's about 10mm longer than the standard shroud, with the standard shroud being about 30mm OD, and our new one being 40mm OD. The next thing we'll show you is how quiet it is. So again, we'll hold it nice and close to the camera, point it in a nice safe direction. So hopefully from that you can tell how quiet it is. Now I will say that the camera auto balances the audio levels, so even if there was a massive discrepancy between the two, it wouldn't necessarily show it on camera. I do try and go through afterwards and match the audio levels so that they sound closer to real world values. But just as a comparison, I would say that our new shroud is pretty much as quiet as the old shroud with an additional moderator. So I'm quite happy with that, especially as the new shroud keeps everything nice and compact. But that's pretty much going to do it for this video guys. So thanks for watching, and we'll see you in the next one.